actually forgotten that I didn't start recording the class before we started. Wow, and this is 7:44. Okay, we can continue. The lecture, as I said earlier, so it's just I make it in such a way that is self-explanatory. So even those that miss what we've talked about so far before I started the recording, so when they go through the material or the slide, so they can still catch up. Okay, so our y, as I'm saying, that a now, when you divide both sides, by the exponential 5t minus 7, so your a will be equals to what? 3 all over 7, where with negative. So now substituting this back to this, what you guess, that is the yp of t is equals to a exponential 5t. So when you substitute for the a, you now have a what? Minus 3 over 7 exponential 5t. So that is what you have now for your particular solution. So now, and that is that for the first problem we are having. So let's see what will happen when we have a particular solution and a particular solution and initial value problem. So this is the initial value problem given to us. Y of 0 is equals to 18 over 7. Y prime of 0 is equals to negative 1 all over 7. So I used to say this every time. So whenever you're having something like this, it's saying that your dependent variable is 18 over 7, while your independent variable is 0. It depends on what your independent variable, it depends on what it is. If it is something that is changing with respect of time, so you have it to be t. And if it is another thing again, so but normally what you have inside this bracket is always your what? Your independent variable. Okay. So we know that the general solution will be of the form this. When we look at this problem again, what we just only added to this question is just like the example one, but an initial value problem is just what is added to this. That's differentiated from the first one. So let me go back there. So look at it here. So this is what differentiate them. Here we are giving IVP. Okay, let's continue. And we already have both the complementary and particular solution from the first example. Yeah, so you've already know how to express this, and we even have the solution in our first example. So we don't really need to do any extra work for this problem anymore. Okay, so we've solved for the particular solution, which is the right hand side, and the answer is what? Minus 3 over 7 exponential 5t. Why for the uh why for the complementary solution we have this c1 exponential minus 2t plus c2 exponential 60. So we've established the two relationship already. Okay, so that means solving this will be very very easy for us. Okay, now look at it here. Our y of t now is the complementary part plus the particular part, which is the particular solution, and the particular solution is the right hand side that we established, which is minus 3 over 7 exponential 5t. Look at it here. So now, but don't forget, this question is of second order. So when you have your general solution, which is this first line, you have to differentiate it how many times now? Twice, for you to be able to what? Plug it back into the general problem given to us. So general problem given to us. Okay. Now, when we differentiate this, the negative 2 will come down. You have your constant c1 exponential minus 2t plus, you differentiate this, 6 will come down, c2 exponential 6t minus So 5 times 3 will make this to be 15 over 7 exponential 5t. That is, you differentiate it once. And don't forget, so we have the IVP for these two. We have the IVP for ordinary y and the IVP for the first order, but we don't have it for the second order. And even we have it for the second order, we have to differentiate it how many times? Twice again, so that the substitute will now be what? 3 expressions. You have equation 1 for the ordinary y, equation 2 for the y prime, equation 3 for the y prime prime, which is double prime. Okay, so now let us make the substitute. Now, for the ordinary y, you have the dependent variable to be 18 over 7, which is this. Why the independent is 0? Why? That's why this 0, you have it here. Then when you substitute 0 here, your negative 2t will be equals to 0, and anything else to the power of 0 is 1. That's why you have your c1 plus c2. The same thing will happen. That 0 will neutralize this to be what? To be 1. And c2 times 1 also will give us c2 minus 3 all over 7. So you don't need to ask why. So we know why. So then you go to the second one, which is the first order, and make a substitute. But here, the dependent variable or value we are given is negative 1 over 7 is equals to, the same thing will happen, that your 0 you have, we also what? Make this to be what? Exponential s to the power of 0, and which is 1. So you have minus 2c1 plus 6c2 minus 15 over 7. Okay, this is equation 1, this is equation 2. And you know, in mathematics, so whenever you are solving, so you have to be solving everything and be what? Be very, very observant of what you are doing and conscious again that, okay, what am I doing? Okay, so this thing that I'm doing, where is it going to lead me to? So now, having this now, what we see this now by inspection, we know is a what? Is a linear expression, which is a simultaneous equation. So you can solve this using matrix or using all the methods you've learned so far in solving your simultaneous equation. So now, after the class, you can solve it, but after solving it, your C1 will be equals to 2 and C2 will be equals to 1. But if you don't get it to be this, so you can tell me in our next class and we look into it together. So the actual solution is, then now you have your C1. And what is the work of the IVP? Is for you to have a value for the arbitrary constant. So instead of writing C1 and C2 now, so you have your what? You have your 2 and you have your 1. So that's why you have y of t is equals to 2 exponential minus 2t plus exponential 6t minus 3 over 7 exponential 5t. So that is all about the example number 2. So example number 3. Now, the particular solution is a trig function. So what is going to happen when we have a trig function? So we are going to see that with our eyes. So find a particular solution. So when you check, I try to uh be using just the same linear expression here, so just for us to make it more easier. So you see that in our example 1 and example 2 and this example 3, we are still using y prime prime minus 4y prime minus 12y. We're still using the same thing, so that when we have the value, so we only focus only on the particular solution. So the solution, so let's note that we should probably find the complementary solution before we proceed. So we know this, so we don't need to find it. So what is just left for us here now is just to guess what we are going to use to substitute this right hand side. And the first one we solve, if you can still recall, is 3 exponential 5t. We remove that 3, we put a. Now we are having sine 2t. So the same thing, you attach a constant a sine 2t. So now let us see what will happen. we are going to differentiate it how many times? Twice, and substitute it back into this expression. Okay, so when you differentiate sine 2t twice, you have negative minus 4a sine 2t, because from cos it is going to go back to sine again because you are differentiating it twice. Minus this 4 is from the equation, which is constant. 2a cos 2t is when you differentiate this one. Then minus 12 from the equation. Then y, you just substitute the y directly, is equals to the right hand side, which is sine 2t. Okay, so when you collect the like time, when you look at this, so you collect the like time and you have this minus 6a sine 2t, the one with sine, you collect the like time together, while with the one with cos, you bring them together also. So you end up with this minus 16a sine 2t minus 8a cos 2t is equals to sine 2t. So seeing this mathematically, from our partial equation, so you know how we used to solve this. So you check what you're having in the left hand side and see if it's having a correspondent here, and you check the coefficient of the correspondent is what you equate to this left hand side on each. So the sine you check, the cos you check. Okay, so now we need to pick a so that we get the same function on both sides of the equal sign. This means that the coefficient of the sine and cosine must be what? Must be equal. Okay, so let's see what is going to happen when we take the cos first, which is cos 2t, such that what is the coefficient of it is minus 8a. So is equals to what? 0. Where do we get our 0 from? It's not having a correspondent from the right hand side here. Here you are only having sine 2t. So there is no cos, nothing for cos here. That is why you're having 0 here. And this implies what? Your a is equals to 0. So while for the sine 2t, such that what is the coefficient of it is minus 16a and is equals to what? 1, because you have it here at the right hand side and it's only one time you have it. So that's why you equate it to 1. So this implies that what? A is equals to minus 1 over 16. So notice two things. First, since there is no cosine on the right hand side, as I said, so what this means is that our initial guess was what? Was automatically wrong because of what? You have one a here to be 0 and another a to be negative 1 over 16, and in the same question. So how are you going to undo that? So mathematically, I don't think it's allowed. So that is why he said we guessed wrong. And what's our guess? Don't forget, our guess is y of p of t is equals to a sine 2t. So we guess it wrong because we are having two value for a which are different. Okay, so that is what this long statement is saying. So now we are now going to what? Make another guess. So that means definitely whenever your problem is having sine 2t as a particular particular expression, so at the right hand side, that means what you will guess automatically is not what? Is not this. Sorry. Yeah, it's not this a sine 2t, because it's not going to work. You end up in having two value for your what? For your a, as what happened here. So now let's see when we make another guess. So here we are guessing y p of t is equal to a cos 2t. Now we are adding plus b sine 2t. You do the same thing. So you differentiate it how many times? Twice, just like you did for the other one. So after differentiating it twice, you now what substitute it back into the uh problem given to you. So then you have minus 4 a cos 2t minus 4b sine 2t and so on. So it's a long expression. So so we have minus 4a cos 2t minus 4b sine 2t minus 4 into minus 2a sine 2t plus 2b cos 2t minus, okay, yeah, the minus, wow, I think the line is not enough for it to, it was compressed here. So I'll reduce the font before sending the slide into the Telegram. So what we have is minus, after this b sine cos 2t, what we have is minus 12 a cos 2t plus b sine 2t is equals to what you have in the right hand side, which is the what? Sine 2t. Okay, sine 2t, don't forget from our problem. So this, when you now factorize those with cos, those with sine, so you have this minus 4a minus 8b minus 12a with factor of what? Cos 2t plus minus 4b plus 8a minus 12b, the one with sine together, then is equals to the right hand side. So now, what is the next thing? The next thing is for us to be, okay, you add them together, then you end up with okay, the network was interrupted. Okay, as I was saying, we now have minus 16a minus 8b minus 6 sine 2t is equals to this. So now what is the next thing now? The next thing is for us to be what? To equal. Okay, so it's now for us to equate this cos and sine. So cos 2t is such that what's the coefficient of it? You have minus 16a minus 8b is equals to 0. So is equals to 0. Don't forget that 0 still comes from the right hand side, the particular solution, which is the sine 2t. So there's no cos there from the initial problem given to us. Look at it here. Oh, sorry. Look at it here. Y prime prime minus 4y prime minus 12y is equals to sine 2t. So you only have sine 2t here, but no cos. That is why you are having that cos to be equated to what? To 0. Yeah, look at it here. So to be equated, to be equal to 0. So now the sine 2t now such that 8a, the coefficient of it, minus 16b is equals to 1. You know, we have the sine from the problem given to us, and it's only one time that it repeats itself. No any multiplication there. So now from there, when you equate or when you take this to the left hand side, yeah, when you take it to the left hand side, so you get your a down. So after getting your a, Then you now substitute the value of your A into this equation 2. Then you end up in having this A is equals to 1 over 40. Then B, that is solving it simultaneously, just like the first one we solve. So you have your A to be equals to 1 over 40, then B to be equals to minus 1 over 20. So you can still check that or confirm it after the class. It's just a simultaneous equation. And look at it here. So minus 16A minus 8B equals to 0, equation 1. 8A minus 16B equals to 1, equation 2. So just solve it simultaneously using any method you like, either graphical or the elimination method and so on. So, or substitution. So we found the constants A and B, and it's needed for us to go and substitute it back. So, and we're going to do that. So bringing it down here, you have your Y here, Y P of T is equals to A. So that A, you're getting the value for it. Then your B also, you're getting the value of it. So, and which is this? 1 over 20, 1 over 40. So it's just very, very simple as that. So now, we've solved example 1, the one with exponential. We solve the second one with IVP. We solve the third one with trig function. So now we want to check polynomial and see what will happen in the polynomial, the cubic polynomial. So what is the guess? What are you going to guess for it? So this was the guess. So I think the prerequisite for this on the timing coefficient, we need to go and revisit that our partial equation very well. So when you're having the cubic, the guess supposed to be this: A, which is the first constant, t cube plus B, t square. Then the third one we carry C, then T, then the last one we carry the constant only. Okay, so you differentiate twice as we used to do it. After differentiating twice, you now substitute it, and which is this. So you have minus, you have your 6A. So down here, then minus 12A, all these minus 12A, minus 4, they are all constant. So you have the first line. So the next line, when you multiply all the bracket out, so you have this second line. Then, so if I said I want to be solving all these, opening the bracket, so it's going to consume much of our time. So you just have it to be minus 12 A t cube plus minus 12A minus 12B for the t square. That is, I'm trying to factor them out. Then 6A minus 6B minus 12C, that one, you factor T outside. And the last one are the ones with the constant, which is plus 2B minus 4C minus 12D is equals to what? The right hand side. 2t cubed minus t plus 3. So after getting them down, what is the next thing? You start equating them, as you know. So you first of all, you take the highest power, which is the cube. You take the cube such that you now write all this. That is the coefficient of it. So which is what we'll be having next. Look at it here. So t cube such that minus 12a is only what we are left with for the 12 cube, minus 12a. So minus 12a now is equals to, going back here, look at the t cube is having coefficient of what? 2. So you have to equate it to that, which is it, which is here. So minus 12a is equals to 2. So from here now, automatically our a is equals to negative 1 over 6. You take the second one such that minus 12a minus 12b is equals to, now you go back there and check t square. Do we have t square? No. From our right hand side there, we didn't have any t square. So for that reason, it's going to be 0. So that is why you have it to be 0 here. So you substitute your a Down, since you have the value for it, you take it to the other side here, so you get the value for your b to be 1 over 6 also. So subsequently, you substitute for the value of your a, you know it, value of your b, you know it, you get the value of your what? The value of your c, and which is negative 1 over 9. When you get the 3 down, so the last one, which are the constant, and you have the constant also there, I think, yeah, it is equal to 3. So you equate it to 3 here. Then you substitute all the value of b, c to get your d, and d is equal to what? 5 all over 7. 5 all over 7. So notice that in this case, it was very easy to solve for the constant. But before we arrive at this, don't forget, we first of all use what? 1 a cos, sorry, a sine 2t. And it happens that we do what? We guess wrong because we have our a in a multiple of 2 places, which are not the same thing. And even the a are the same, you have it to give you the same values. No other. One give us 0 and the other one give us another value, which are not the same thing. So that is why we have to guess for another thing. So guessing for another thing, that is what make us to use this y of t of this a cos 2t plus sine 2t. So which gave us a value for all this value of our a, b, c, and our d. So when it can satisfy all these, so that means we guess right. So then the second equation, which is, yeah, give the b etc. So a particular solution for this differential equation is now this. So you substitute for your a, which is minus 1 over 6, b is 1 over 6 t square, c is minus 1 over 9, then d is minus, which is the constant one, they are minus 5 all over 2c. So which is that for that question also. Okay, so these are a summary of the table of what to use whenever we have undetermined coefficient. So anytime we have our g of t that look like all this, so look at the first one, a exponential beta t. So what you substitute for it, your y of t guess will be a, which is the arbitrary constant, exponential 5t. Then when you have a cos bt, this is what you use, a cos bt plus b sine bt. The same thing again when you're having sine, you are still going to use a cos bt plus, which is like the one we just finished solving now, plus b sine bt. Okay, so now when you now have the combination of the two, you have cos and you have sine. So the guess will be what? Will still be a cos bt and beta t plus b sine beta t. Yeah, and so on. So we can see that, we can see the relationship or the association of the exponential and the trig function. But don't forget, from our introduction, we said we can have a linear combination of them, and we've not yet talked about it. So maybe that is what we talk about in our next slide. So then the nth degree polynomial, which is this, so which is the last one we treated. So we have it to be a n t n plus a n minus 1 to be reducing until you get to the last one. So this is the summary. Sorry. So this is the summary of the table. So we can get this down somewhere so that whenever we are in the examination or when we are having assignments, so to make it more easier for us, so you know what to guess whenever you have it written somewhere. Okay, now example number 5. This example number 5 is now the example that talk about the linear combination. So you have a product, here you have exponential, and you have should I call it a variable. So let's see what is going to happen. When you notice again, you see that the left hand side is still the same thing, is what we are still using, what we established so far. So next step, what will happen? Let's start by writing down the guesses. Why do we use guesses for this? Because it's a linear combination. You are not using only a single guess. So, and as usual, you know the guess for the exponential already. You know it from your mind even before I said it. Now, so the guess that we will be uh maybe worried about is that of t, and which is the polynomial of what we talk about in the table. That is the last line in the table. So now let's see how to combine them together. So the guess for the t would be at plus b, because it's only a single one and it's not having square. Even it's having square, you start with square, at square, then the second one bt, then the last one plus c. So but this is having only t, so it will just carry only at plus b. Okay, so why the guess for the exponential will be what? Will be c. Don't forget the first one we use a, so don't be confused. We use a just because it's the only one we're having there. But here now, we've already used arbitrary constant a and b for the t. So you can't use a again for the exponential to avoid confusion. So now, since we have got a product of two functions, it seems like taking a product of the guess for the individual piece might work. Doing this would give what we have in here. C exponential 40 for the exponent, y this for the polynomial at plus b. Yeah. So now, how are we going to work on this? So how are we going to work on this? And the linear combination is only two, but now we are having three arbitrary constants. Okay, so let's see what will happen. So, however, we will have problem with this, yes, because this is three arbitrary constants. So how are we going to go about it? As we see, when we plug our guess into the differential equation, we will only get two equations out of this. The problem is that with this guess, so with what guess, so we have got three unknown constants, c, a, and b, with only two equations. So we won't be able to solve for all the constants. So what is going to happen is that you are going to do what? You are going to combine them by multiplying that c throughout the bracket. And which is this? So when you multiply it, you have exponential 40 outside as it is before. Then ACT BC when you multiply the c inside. Okay. So they are all constant, and you know the law of constant, you can use the constants to replace constant, you can equate it to another constant. That is what I mean. So if you have a and you decide not to use a again, you can see that okay, a is equals to b. So you will just state it down, that so you equate it back, it's no more your a, so nobody will hold you responsible that you should come and explain anything, so provided is mathematically stated, so well stated. So now ACT, what are we saying? So the ACT, you can use it, you can use 80 to represent it back because it's still constant, and go away with the C. Why the BC, you can write it as B because it's what? It is still constant. So it's allowed mathematically like this. So now y of t is now equals to exponential 40 of at plus b. Now we have our arbitrary constant as A and B. So now we are good to go. So now, what's going to happen now after this relationship? I'm sorry. Okay, after this relationship, so what are we going to do now? just as usual, we are going to differentiate twice. And differentiating these twice is going to be very, very long, as we know that we are going to adopt what we call product rule here. So it's going to be very, very long. So that is what give us what is here. So exponential 40, 1680 plus 16b plus 8a minus 4. Don't forget that minus 4 from our equation. Then what we have here, exponential 40 into 4at. That is when you differentiate once, plus 4b plus a minus this 12 again from the constant that you're having. Then exponential 40 at plus b. Don't forget, this is our y. I mean this is our y. Okay, so having substituted this into our expression, then is equals to our right hand side, which is t exponential 40. So it's very straightforward and it's not confusing. So the moment you just get this differentiated, so you are good to go. You just come and substitute it here, then equate it to the right hand side. Okay, so after opening the bracket, so the one with t exponential 40, you factor them in one place. The one with only ordinary exponential 40, you factor them in one place. Don't forget, our arbitrary constant is only what? A and B. So definitely you must have only two two expression also here in the left hand side, so that when you equate it, so that each equation will be equate to the equivalent value that is having in the particular solution at the right hand side. Okay, so now we have minus, when you add up 16a minus 16a, so they will be gone. You'll be left with only minus 12a, which is what you have here. T exponential 40, yeah. Then plus, when you add up all what you're having inside this bracket, also here, you'll be left with 4a minus 12b. Then what you're having outside, exponential 40, then is equals to the right hand side, which is t exponential 40. Okay, so the one with exponential with t, t exponential 40, the coefficient of it is minus 12a, then is equals to 1. How is it equals to 1? So when you come here, you have it here, t exponential 40. You have it at your right hand side once. So that is why it's equals to 1. You equate it to 1. So from here, our a is equals to what? You divide both sides by 12, negative 12. Then you have a is equals to negative 1 over 12. Then 4 exponential 40, which is the second one, which is this exponential 40. So you equate this to what? You equate it to 0. So I'm sorry, I'm trying to take water. Okay. So 4a minus 12b is equals to 0, because you don't have exponential 40 only standing single-handedly in the right hand side of our problem given to us. So for that reason, you equate it to be equals to 0, which implies that what? You know the value for your a, you substitute it down, then from your a, you can get your b to be negative 1 over 36. So you now do what? You now substitute your a and b back into the y of t. Yeah, yes, into this place, into your y of t, and we have it to be equals to exponential 40 outside. Then yeah, look at it here, exponential 40 outside. Then the value for your a, you put it there minus that b here. When you take the LCM, so you have what you have here, 1 all over 3, 1 over 36, negative 1 over 36 into 3t plus 1. That's when you take the LCM and you factor it out, then exponential 4t. Okay, so before we move to another topic, let us quickly summarize what we have done so far here. And that table alone summarizes everything for us. So whenever we are having undetermined coefficients, I said, so the two side, both the left hand side and the right hand side, are very, very important for us. So you find the complementary solution in the left hand side, while the particular solution in the right hand side. So, but you know what to guess. It depends on what you have, if it is polynomial, if it is exponential, if it is trigonometry, if it is a linear combination of them. So you know what to guess. So whenever you get wrong or you guess wrong and you couldn't have a solution, so you quickly know that the problem is from the what? From the guess. You rush back, you guess another thing again. So this is just very what? It's just very obvious, very clear. When you are right, you know you are right. So the next we are going to talk on today to talk about is variation of parameters. Variation of parameters. So method for the non-homogeneous equation also. Okay. So undetermined coefficient. Someone want to join? Let me admit the person. Undetermined coefficient method. So when we have this, just like what we have when we introduce the undetermined coefficient. So we have something, one expression like this. So p of t y prime prime plus q. So q of t y prime plus r of t y is equals to g of t. So and reduces the problem to algebra. You can see we use some partial method to get the value of our a, b, c, and we substitute it in back to the expression that we guess. So and it make it what? To be more simple in algebra form. So and we also say that it is used for a what? For a limited class of function if you don't have a complex one. So you can think of using the undetermined coefficient. So now we now want to look into this variation of parameters. Okay, what is this also talking about? How are we going to approach it? So we should also put our mind at rest. It will not be so hard, but the only thing is just that these things are just like prerequisite to each other. You can't jump one and you expect that you understand the one we are doing currently. No, it will not be done in that way. So rather, you have to like follow them the way we are following it step by steps in our curriculum. So when you are doing that, so you realize that whatever questions, so you'll be able to undo it without, or let me just say that, don't let me say that without stress. Let me just say that with a less stress. So variation of parameter is a more general method applicable in many cases, but it has a disadvantage. So that means why we didn't bring the advantage here is might be because the advantage of all the ones, the undetermined coefficient, the constant coefficient, the variable coefficient, so that we've been talking about, so they share the same thing with them, but this is having a disadvantage. So let us see what this that's my disadvantage is all about. Number one, complementary solution is essential. unlike undetermined coefficient where it is advisable but not required. So you see, in the undetermined coefficient, as you can see also, we see that we focus without that right hand side, you can't do anything. You cannot do anything except for that question 2 that we solve, which is the IVP. You see, so without giving that right hand side, that non-homogeneous part, so you can't do anything. So completion of the method involve integral. So that is the complexity that will be a country here. So it will involve integrals, and you know how integral used to be, and there is no guarantee of being able to solve them. So sometimes you can have an integral that will be very, very complex to handle. So that is what it's saying. I think that is the only two disadvantage we'll be having or we'll be facing here, the challenge we'll be facing. So why a formula for the particular solution can always be written, finding it may be challenging if integral are too difficult or if the complementary solution is unknown. Okay, so we are going to derive the formula before we start using it, the variation of parameters. So we are going to derive the formula, and you know in mathematics, so mathematicians, they always like proving things first, so that when you prove it and you see the formula, anytime you want to solve it, so due to the proof, so you can quickly record the formula and apply it, just like the quadratic equation. So that is how, using that completing the square, so you'll be able to derive the general solution, and the general solution will be able to stick what in your head. So the same thing we are going to do for this variation of parameter. We are going to prove it and have or establish one general formula for it, which what we'll be using in solving whatever problem we'll be given. Okay, so let's see this homogeneous equation, because you can't call this non-homogeneous because of what? Our right hand side is having 0. So then whenever you're having homogeneous differential equation, the general solution is this: y of t is equals to c y1 of t plus c2 y2 of t. In our previous class, that is the module 4, I prove something like this. You have your y1, y2. So you later come and put them back. So we also do the same thing here. So now we've agreed that number one is homogeneous differential equation. And number two, this is the general solution to the homogeneous differential equation. Okay. Now, what will happen next? We now have the equation 1, p of t y prime prime plus q of t y prime plus r of ty is equals to 0. This does not change, it's still the same thing. So also recall that in order to write down the complementary solution, so we know that y1 of t and y2 of t are a fundamental set of solution. What we are going to do is see if we can find a pair of function u1 of t and u2 of t. So the essence of the complementary solution is for us to get some certain value from the root. So that is what is happening here. That certain root is what is assumed here to be u1t, u2t. So nothing is done. So we should be following the proofs, please, as it is going. So to find a solution for the given differential equation 1, I think if we have a pen there, we should write down this equation 1. P of t y prime prime plus q of t y prime plus r of t y is equals to 0 somewhere. So when we get it, so that we'll be referring to it as our equation 1. Okay, so equation 1, we aim to derive two equations to determine the two unknown. in our proposed solution. So the first equation result from substituting our proposed solution into equation 1 to satisfy the differential equation, while the second equation arises from making a convenient assumption which will be elaborated upon shortly. Okay, so now when we have our y of t and the right hand side, which is the guess, instead of the root, so you use your y1 of t, y2 of t. So now you now have to, what is the undetermined coefficient method you are going to use? You differentiate this yp of t twice, which is what we did here. So this is the first one. You differentiate it for the first time. You now have y prime of t. You want to differentiate it, which is equals to this. You use the product rule. So u prime of 1 y1 plus u1 y1 prime plus u2 prime y2 plus u2 y1 prime. So here the assumption, mathematicians, so you should understand when they say assumption. So that means they are going to assume something here now, and it's allowed because you want to derive a formula, so you want to make a proof of something. So whatever way you must to use must be what? Must be visible and must be what? Mathematically accepted. Okay, so simply to make the first derivative easier to deal with, we are going to assume that whatever u1 of t and u2 of t are, they will satisfy the following. And what is the following? Look at it here. So from this, we only take u1 prime y1 plus u2 prime y2 is equals to 0 from here. So if is equals to 0, now what will happen? Please, we should just take a time and look at it very well. So we take this and this, so to be equals to 0. So with this assumption, what are you going to be left with? Because you've make this to be 0. So making them to be 0, you'll be left with only what? u1, the one you didn't make to be 0, which is the u1 y1 prime plus u2 y2 prime, which is what we have here. So now the second derivative is, then you now differentiate this. So you differentiate it again, you use the product rule, you have this. So that now you now have the solution for your what? Y prime prime for the p of t. Then for the y prime p of t, you have the solution also. You can now substitute them back into the general one, which is the equation 1. So, and from there you have your p of t to be constant. Yeah, to be constant. So the y prime prime, look at it here. You bring whatever you have, the value you have from your differentiation, look at it inside the bracket. Then the key of t, which is also a constant from the problem given to us. Then the derivative of this y prime p of t, which is this, then you bring it into the bracket. Then plus, so I try to cut it because I don't want to make it longer. It will not be able to, as in the font will be like very, very small. So I don't want it to be that. That's why I cut it down here. I'm bringing the plus here. It's still the same. So the last one, we have our r of t, which is a constant also. Then this u1 y1 plus u2 y2, don't forget, is our y, our initial y p of t. Then is equals to g of t, which is the particular solution. So rearranging this, when you rearrange it, because definitely you must to see those one with common, is either they have u1 prime as what is common within or between 2 to 3 things, or you have the y to be common, or the y prime prime, or the y prime to be common. So this is what we now have. We have, when you sit down, so check it, we have our p of t of all this that we are having in our bracket plus u1. So those one with u1 of t. So p of t. So y prime prime plus q of t, y1 prime plus r of t y1 is just rearranging only. So then the u of 2, don't forget. So seeing this, something should come to your mind, that is what we are doing in our undetermined coefficient. So after everything, you now try to be equating them to the corresponding particular solution at the right hand side. So arranging them, you have all this. So let's see now what will happen. Okay, now both y1 of t and y2 of t are solution. And when they say something is a solution in differential equation, it means that thing is equals to 0. So that when you guess any number, you differentiate it in the number of the derivative you are given, then after substituting it back, you must have that solution back, which is the right hand side. So this is claimed to be a solution, and so the second and third term are 0. You see, when you say that y1 of t and y2 of t are 0, so coming back here, where is the y? So that is, look at it here, the y prime prime, I mean the second line here, y prime prime plus q ty1 prime plus rty1, so is the same thing as what you have here from initial equation 1, and is equals to 0 here. So after opening those brackets, you still have them. So for that reason, you can equate it to be 0. That is what the expression is saying. So here the second line is equals to 0. When you look, this thing repeats itself again in the third line, so you equate it to be 0. And when the second line and the third line are zeros, so you'll be left with only the number 1, which is the p of t only. So that is why we have our p of t, u1 prime plus y1 prime plus u2 prime plus y2 prime plus u1 of t 0. Don't forget that 0 where it comes from. u2 of t 0 again, then is equals to the right hand side, which is g of t. So now we now want to assume our p of t to be equals to 1. So assume, because we are aiming to prove something. So all the possibilities of what you can do that can make it possible for you is what you'll be trying. But just make sure is what is mathematically okay. Don't go and follow a quack method and arrive at what so it cannot be proven mathematically. So don't do that. Now we now assume our p of t to be equals to 1. So when we do that, and this place now that you are seeing your p of t, you put your 1. So definitely g of t over 1 is g of t, which is what you have here. So in other words, we are going to go back and start working with the differential equation. Okay, so after making this p of t to be equals to 1, now we now go back to equation 1. We write it down. This is our equation 1. So if the coefficient of the second derivative isn't 1, divide it out so that it becomes a 1. So what are we saying? This y prime prime, whenever you have it not to be equals to, when the coefficient is not equals to 1, that is, you have to divide. Let's assume you have 2 here, 2y prime prime. So it's saying that you can't have any number under this variation of parameter. That is the difference. You can't have any number attached to this y prime prime. Whatever number you have there, you must to divide it across all terms for it to be standing alone. So the formula that we are going to be getting will assume this. Upon doing this, the two equations that we want to solve for the unknown function are, so this, don't forget, we have already have this to be equals to 0. from here. Look at it here. From this expression of this y1 prime of t. So we have already established it. We have it. We have keep it somewhere to be equals to 0 before. Then from the second one, after this has already neutralized or go away, because when you multiply it by 0, this u1 of t and u2 of t, when you multiply them by 0, so you'll be left with only what? With u1 prime plus y1 prime plus u2 prime plus y2 prime equals to g of t. Yeah. So which is the two of t. So you know where these two, this equation 4 and equation 5, you know where they comes from. Okay. So now let's see now what will happen. So note that in this system, so having seen this, you know, is a linear problem, linear algebra problem. So you can solve it. So now, okay, note that in this system, so we know the two solution, and so the only two unknown here are u1 prime and u2 prime. Solving this solution is actually quite simple. First, solve 5, that is equation 5, which is this, the down expression. So from that equation 5, and plug this into equation 6 and do some simplification. So from this, when you take it to the other side, so you now make u1 prime to be the subject of the formula. So that is why you'll be having this negative u2 prime y2 over y1, or you say that you have minus u2 prime y2 over y1, anyone you wish to say among the two. So now when you have the value for this u1 prime, you can now substitute it back into this expression. Then you substitute all what you have in your u1 prime, then y1 prime as you have it here, plus u2 prime plus y2 prime is equals to g of t. So we are not lost. It's very, very clear. Okay. So now, next step, our u prime prime is now equals to y2 prime minus y2 y1 prime minus y1. That is, you try to factor out y2 prime, and you have this is equals to g of t. Then from there, you can take the LCM, and the LCM is y1. After taking the LCM and the LCM is y1, you can now what? Multiply both side by y1, so that the y1 here will be gone and you'll be left with this. So equals to y1 g of t. Okay, yeah. For you to have your u2 prime, you have to divide both sides by the reciprocal of this. You reciprocate this, that is y1 all over y1 y2 prime minus y2 y1 prime. So that is why you have u2 prime is equals to y1 g of t, which is what you have in the right hand side before, all over y1 y2 prime minus y2 minus y1 prime. Okay, so now you have the value for your u2 prime, but the u1 prime you're having before here, you just use it to get the u2 prime. So now when you have your u2 prime, and the u2 prime is also inside what you're having in your u1, so you can put this u2 prime here, up here, to get your u1 prime. So when you do that, that is where you get your y2 g of t minus, that is minus y2 g of t all over y1 y2 prime minus y2 y1. Now they look alike. The u1 prime and the u2 prime, you can see now they look alike. You have y1 here, you have y2 here. So now let's notice. Okay, so the network was interrupted. Aha. So the formula, the integral we want to, the formula we want to prove since we started this. So it's having W, and the W is from the Roskian function. And in our last class, if you can still recall, so we talk about this Roskian. That is, we said we use it when you want to check if a linear combination is either linearly dependent or linearly independent. Wow. So when you have it to be, what is wrong? Please excuse me. Okay. So when you had, when do we say that a linear combination or a linear expression is linearly independent? Is when you find the what? When you take the matrix and you find a determinant, and the determinant is not equals to zero. So when the determinant is not equals to zero, you see that is what is linearly independent. But when you find it out and the determinant is equals to zero, so you see that is what linearly dependent. So we are going to use the Roskian. That is why we bring it here. So recall that y1 of t and y2 of t. Okay, this is the Roskian. Y and w y1 y2 is equals to y1. So if you can still recall the matrix, yeah, when you go back to the last slide, you see the when you take the determinant, it will be in this form. So the y1, you know how we take the determinant of diagonal. So you multiply this and this, then you take the subtraction. So y2, y1 prime. So if it is not equals to zero, that is the Roskian. And it is what? It is linearly independent if it is not equals to zero. So recall that y1 of t and y2 of t are fundamental set of solutions. And so we know that the Roskians won't be zero automatically because it's proving that it is linearly independent. So finally, all that we need to do is integrate 8 and 9. So what is the 8 and 9? So what we have here, that is the u1 and u2. We want to integrate them. So and when you integrate them, what is going to happen? You know, when you integrate a derivative, they will cancel each other and you will left with only u1. And when you integrate, yes, the second derivative, which is the u2, so u2, so that integral will go away with the derivative, they will be left with only u2. So that is why you have it here. u1 of t is equals to negative from what you have there in the previous slide. So negative of integral of y to d of t all over the Roskian w y1 y2 the t. So the same thing happened here. The integral has gone away with the differential. You are left with only u2 of t is equals to integral of y1 d of t all over w y1 y2 dt. So now, okay, what is going to happen? So provided we can do this integral, a particular solution to the differential equation is yp of t, which is not new, y1 u1 plus y2 u2. So then, as I was saying, after getting our u1, u2, please, we need to go back to this proof. It's even advisable for us to go through it because that is a proof for you. You have to go back, look at it line by line. So you now later say that okay, this is how it is. That is how that one is. So you now be getting it and be putting them together. So this y p of t is what we have. That is our guess. Don't forget. So we have our y1. y2. Then but here now you have the value for your u1 and u2. So using this expression now, that yp of t now will be equals to y1, but you have the negative for your u1. So that's why you have your negative. Integral of, you substitute your u1 here, plus the y2 here, integral of u2, you substitute it here. So now this is now the formula we'll be using anytime we want to approach any problem under the variation of parameter. So it involves integral, you find your y, you find your u, you find the w. Okay, so let us just see. I think we only have one example for it, and we have only 5 minutes. So let us quickly look at the example before the time. Example number 1. Find a general solution to the following differential equation: 2y prime prime plus 18y is equals to 6 tan 3t. So don't forget, the first thing is that I said whenever you want to solve any problem under this variation of parameter, you have to be what? Very, very observant, because your y prime prime must stand alone without any constant. So since the formula for the variation of parameter require a coefficient of 1 in front of the second derivative, so let's take care of that before we forget. So what are we going to do? You divide both sides by 2. And when you divide both sides by 2, you'll be left with y prime prime plus 9y is equals to 3 tan 3t. So from there, verify that the complementary solution for this expression or for this differential equation is, so what you have here. So what I'm saying here is that you just need to go and solve this using all the method we are using in solving them. Use the guess. When you guess, get the auxiliary equation, solve the quadratic, then the root will be complex. That's why you're having c1 cos 3t plus c2 sin 3t. So this is the general expression from the complementary solution. So we have our y1 to be equals to cos 3t, then our y2 to be equals to sin 3t. So and after having your y and y2, the next thing is for you to find your what? The Roscan. Because from the Roscan, look at it here. You have is a function of y1 and y of 2, and which is equals to the determinant, which is y1 y2 prime minus y2 y1 prime, and it must not be equals to what? 0. Okay, so now you know your y1, you bring it down. You know your y2, you bring it down. Now you now take the derivative of it. Taking the derivative of cos 3t, you have minus 3 from the cos, because the derivative of cos will give you minus sine. Yeah, so that 3 that is outside is using the product rule, that is d dt of what? Cos 3t. So you have to differentiate what is inside this bracket, which is 3t, and when you differentiate 3t, you have 3. That is why you have your 3 outside. So the same thing applicable to this sin 3t also. 3 cos 3t is what we have. Then taking the determinant, you have cos 3t times 3 cos 3t, which is 3 cos square 3t. Then the other side, you have negative, but because of the negative here, it will change this to positive. So then you have 3 sin 3t multiplied by sin 3t, you have 3 sin square 3t. And this is a 3 function. You factorize the 3 outside, you'll be having cos square 3t plus sin square 3t. And this will give us what? This will give us uh it will give us 1. Yeah. So this will give us 1. And 3 times 1 will give us what? Will give us 3. So which is what we have here. So you've proved that the Roscan is equals to 3. So the moment you just have this to be equals to 0, you mean you know you can't even proceed anymore. The moment you have this Roscan to be equals to 0, there's no way you could what proceed forward, because you can't have a fraction over zero. Yeah, you can't have it. Even in your calculator, you'll be having a syntax error. So you can't write a mathematics expression as something over zero. No, 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 no. So that means the Roscan, the moment you just come here and you have your Roscan to be equals to zero, just generalize and conclude that this equation can be what solved further. So let's see. But because it's equals to 3 now, we can move on with the solution. So the particular solution is then this now. So y of t is now equals to, from the formula, this is the formula. You have y1 outside. So don't forget, and our y1 is cos 3t, y2 is sin 3t. So that is why you are having it here. Don't be looking at it as something that is, what is this? No. So it's just a substitute. Cos 3t is that's y1. So the Roscan, which is the 3, look at it here. Then, what is the y1 g of t? So is what you're having here, which is the 3 sine 3t tan 3. So, but also, all these three functions, how they work. So you'll be like, you have to know all the identities. This, you cancel this, and this. So you need to go and revisit trig. I said it in our last class. So starting to reduce this complexity, to reduce it, to be able to solve it. When we check out this tan 3t alone is the same thing as what? Sine over cos. So sine over cos, when you substitute it, you have sine 3t times sine 3t over cos 3t. So then when you have it to be so, sine 3t times sine 3t that you have on top will give you sine square 3t. Then that sine square 3t is what will now give you 1 minus cos square 3t that you're having here. So just follow the step. You first of all change this tan 3t to sine 3t over cos 3t. Then that sine times sine will give you this square here, where the 3 and 3 will cancel away each other. So we have 1 minus cos square 3t over cos 3t. So which is equals to 1 minus cos 3t also. You can write it in that way. Minus cos square 3t all over cos 3t. So then 1 over cos 3t alone is the same thing as what? Sec 3t. So minus cos square 3t that we have, it will go away. 1 and cos square 3t over cos 3t. So 1 will go away with 1. We'll be left with only 1. So that's why you have minus cos 3t dt. Then plus, so what you have now in this side, sin 3t, you bring it down. This one is not that very complex. So here now, when you change this tan 3t to sine 3t over cos 3t, so 3 will cancel 3. Then cos will go away with this cos. Cos will cross cos away. You'll be left with only what? Reduce it to this. So from here, when you take the integral of sec 3t minus cos 3t dt, so you have nothing but ln. You integrate tan 3t. Am I communicating? So when you okay, the integral of sec 3t will give you the lane sec 3t plus tan 3t. Why the integral of this minus cos 3t will give us minus sine 3t? Because you know the integral is not like the differential. When you differentiate, is when you have negative sign. But when you integrate, you have positive. That is why the sign will not change here. So plus the sine 3t that you have here, you still have it. But when you integrate what you have here, so you differentiate what you have inside and divide it by this. That is why you have your 1 over 3. So then the integral of sine 3t itself is now negative cos 3t. So I break this down to this level. So you now have minus cos 3t over 3 ln sec 3 plus tan 3. So then the general solution so is now this. The complementary solution that we have before from the left hand side after taking the auxiliary auxiliary solution, finding the quadratic. So I said you have it to be complex roots. So which is this c1 cos 3t plus c2 sine 3t, then minus the what you are having in your particular integral, which is what is this minus. So you come and add them together. So it's still following the same trend, the same format. That is, the general solution will be complementary solution plus the particular integral. So which is what we have here. So what is the difference now of what we just did today? In the first one, the undetermined coefficient, when you go to the right hand side, which is the particular solution, so you do nothing but you are going to guess. After you make a guess, you run it. After running it, if it works, so after getting everything, you still come and you still come and substitute it back, then put it in your general equation. So in this variation of parameter, number one thing that must be popping in your heart every time is that y prime prime must stand what alone. It must have a coefficient of only one. Then from there you get your Roskian, you get your y1, and so on and so forth. So maybe our revision in our next class or after the uh, midterm examination will be some examples again under this variation of parameter, because I only bring only one example here. So the next slide is this. Thanks so much for listening. We meet again after the midterm examination. So I know.
Okay, thank you. Thank you.
Okay,
Thank
you're
you.
welcome.
We'll just study it and see how best we can get on it. So,
Okay, so I'll try as much as I can to get some problems and solutions. So I will send it into the group so that you can practice them. So after practicing them, then I'll send the solution maybe in the next day so that you can just verify if what you have done is right or wrong. So at least
okay.
that will prepare you against the examination you're having. Thank you
Okay.
very much.
That's all. Thank you.
Bye bye.
Good night.
Good night.